Okay, before you get into this video, this lesson, I want to make sure that you have reviewed the natural logarithm and how logs work. So make sure you've done that page and the homework page 375, numbers 3 to 6. Okay, so if we have y equals natural log or ln x, then we could also rewrite this as e to the y equals x. And when we take the derivative of, e to the y of x, well, it's going to be 1. And if we rearrange to show the derivative of y, then we're going to have 1 over e to the y. And I know that e to the y is x because of over here. So the derivative of y with respect to x is actually 1 over x. So this gives us a new rule. So similar to our work with the natural base e, when taking the derivative of the ln function, we need to use the chain rule for the argument, so for whatever is inside the function. So the derivative of ln u is just 1 over u, and then the derivative of u. And then the derivative of ln, where we have a function in there, is 1 over the function, and then the derivative of the function, which could also be written the derivative g of x over just the function g of x. So let's see what this actually looks like. All right, so let's keep this in view. Derivative of y. So I have ln x to the 4. So the rule says, because that's actually 1 over x to the 4, and then the derivative of the argument, which is 4x cubed. Just clean that up a little bit. So we have 4x cubed over x to the 4. That can be simplified to just 4 over x. Let's try it on. Derivative of y with respect to x. So a power rule here, first thing I have to do is take the power, reduce the power by 1. And now I'm going to take the derivative of what's inside the bracket there. Derivative of ln x is 1 over x. And now I'm just going to reorganize that so that it looks cleaned up. Let's try this one. Okay, so now I have a quotient rule here, but first I also have the ln. So first, I'm actually going to rewrite this as 2 different functions just to help simplify. So the rule is if this is being divided and they have the same base, then I can actually just separate them and subtract them. Now I can just take the derivative of the first one, which is 1 over 2 to the x plus 1, and then the derivative of the argument, which is just 2, and then subtract 1 over x squared, and then the derivative of the argument, which is 2x. And now I'm going to just rewrite that. And actually I can simplify this, get rid of that guy. 2 over 2x plus 1 minus 2 over x. Okay, last one, I've got a chain rule here and a ln function. So I'm going to apply all the things. First up, take the derivative of the first. Keep the second. Then add, keep the first. Derivative of the second. And take the derivative of the argument, which is 6x minus 2. And I'm going to look and see I actually have a like term here of x squared. I'm going to pull that out. I have 3 on 3x squared minus 2x plus, we still have an x on the top, 6x minus 2 all over 3x squared minus 2x. And then I'm done. Okay, for homework, please do page 383, number 1, and skip I.